All right. So what best practices should you consider when you want to configure data guard? So primarily, the data guard is a very network intensive process, obviously, because it is going to be shipping redos to your standby environment. So the biggest or the most important thing to consider is how to configure the network to allow for optimum data guard transport. Network would mean both of those two things, the actual network itself and the Oracle's net services. We should optimize to be able to handle the necessary redo transport. Additionally, we should make sure that the redo log groups are configured and set up on the fastest portion of the storage, which is the flash storage. Why? Because obviously that will reduce lag in terms of I/O. The second aspect of tuning data guard is to make sure that the apply on the standby database is happening optimally. We can use different Oracle database monitoring features to identify how the apply performance currently is and tune the coordinator and the recovery slaves to optimize that performance. Additionally, we can use a specific feature of the Oracle Exadata Database Machine, which is called the hybrid columnar compression. What that does is it stores data on the disk in a compressed format and does it on the fly transparently. So the end user does not notice any significant performance impact of the columnar compression. However, there is up to a 78% reduction in the volume of redo and network that gets utilized, which obviously means that your apply or your transport is much faster because there's a 78% reduction in the amount of data that needs to be transported from one side to another. All right, so how do we configure data guard for automatic client failover? So using the server control features of the clusterware, we can set up the standby database or the standby site as a physical or a snapshot standby depending on what we choose it to be. And then we can configure the data guard broker, which is required for complete automation, to detect failures on the primary database and automatically switch the standby database role to a primary. The data guard broker also issues FAN notifications so that your applications that are FAN compliant can automatically and transparently fail over to the standby database. This is typically how you would, this is typically how you would configure connection parameters or TNS names parameters on your client applications. So as you can see, we've got multiple descriptions set up, first for the primary, which is the, as you can see, the Austin scan, and then for the secondary, which is the Houston scan. So between the two descriptions, we've got load balancing disabled because obviously data guard does not allow for load balancing, but failover is enabled, which means if an application attempts to connect to the primary database is unable to do so, it will automatically fail over to the secondary application, which is the standby database. Reference configurations.